Good morning, my dear students. Now, welcome to the video 1 on the chapter Dielectrics. Here, what is meant by dielectrics and all that? Here, whatever the material is there that is in the battery now, it is nothing but dielectric. Dielectrics are nothing but insulating materials. Dielectrics are nothing but what? Insulating materials. Then you would ask question, then what is the difference between the insulators and dielectrics? Here, dielectrics are used to store the electric charges, This is what is happening in the mobile battery and laptop battery and all that. Dielectrics are nothing but what? They are used to what? To store the electric charges. Just now I told you, insulators are nothing but what? Dielectrics. But what is the purpose of the insulators? The insulators resist the or restrict the flow of current. When a potential difference is applied. Please note down that. What is the difference? Insulators, what happens now? Whenever the insulators are used in any circuits, it restricts the what? The flow of current when a potential difference is what? Applied. Whereas the purpose of the dielectric material is what? It is used to store the what? Electric charge. It is a bank of electric charge, you can say that. All your mobile battery and also in the laptop battery, there we are using the what? Dielectrics materials we are using. But remember, all insulators are not dielectric. Very important point. All insulators are not dielectrics. All insulators are not dielectric. But all dielectrics are insulators. We are using any ethane, methane, HCl, hydrochloric acid, mica sheet. These are all comes under the what? Dielectric. Example, paper sheet, mica, hydrochloric acid, HCl. These are all comes under the what? Category of what? Dielectrics. Now the question arises in your mind. Any one example that is what? I told you that is all insulators are what? Not dielectric. All insulators are not dielectric. Then give me one example. Example is air. Air is a good insulator. That you know that it is using thermos flask and all that. But at the same time, it is not at all dielectric material, that is. Okay. Now, what are dielectrics? Dielectrics are the special kind of materials or nothing but insulators. They are used to store the what? Electric charges. Now, let us think it how there is where the people are using the dielectrics, how it works and how it stores the what? Electric charges and all that. I will go on explain by using some basic definitions and all that. Okay. Now, I will deal with some definitions first. I am using the word dipole moment. That is what? Dipole moment. There are two types of dipole moment. One is electric dipole moment, another one is magnetic dipole moment. But in this chapter, entire chapter, we are dealing with the electric dipole moment. What is a dipole moment? First I'll give the example, then you easily can understand the definition that is. Suppose hydrochloric acid is there. Here it is H is plus and Cl is what? Minus. Here in HCl, this hydrogen ion is there, no? This is hydrogen ion and this is chlorine ion. This is plus Q and this is what? Minus Q, student. This is plus Q and this is what? Minus. Both the magnitude of the charge on the hydrogen and also on the chlorine, both are same. Magnitude is same, but only what? Opposite. This is positively charged and this is what? Negatively charged. These two dipoles are separated by distance r. This is called r. This is called as an what? Dipole moment equal to dipole moment equal to dipole moment. One of the charge, either this charge or this charge, because the magnitude is what? Same. And the distance between the charge is nothing but dipole moment. It is called as a dipole moment. Here, sometimes we can dipole moment, some books they will write mu. Mu equal to Q into what? R here. Next question is arises, what are the SI? What is the SI unit of it? Is it scalar quantity or vector quantity? No doubt. Here it is in a vector quantity. Mu bar equal to Q into what? R bar. Here distance is a vector quantity, charge is a scalar quantity and dipole moment is a what? Vector quantity. Then if at all if it is a vector quantity, then you will ask a question, what is the direction of the dipole moment? The direction of the dipole moment is always represented from negative to positive, student. This is mu bar. How is it represented? From negative charge to what? Positive charge here. Next, what is the SI unit of it? SI unit. The charge unit is what? Coulomb. Distance is what? Meter. That is SI unit is a coulomb meter is the SI unit of what? Dipole moment. I'll define once again. What is dipole moment? Dipole moment means what? Two equal and opposite charges separated by finite distance is called as an what? Dipole moment. Mathematically, how you are writing here? Dipole moment equal to one of the charge and distance between the two charges. Normally, this distance r is there now. This r, it is 10 to the power of minus 6 meter onward. This is the minimum distance. It is the minimum distance between the two equal and opposite charges. Another example is sodium chloride, Na plus Cl minus. They are also separated by what? Finite distance and all. It is also called as what? Dipole moment. Next. What are dielectrics? Dielectrics are nothing but special kind of materials or nothing but what? Insulators. And it stores the what? Electric charges in it. Okay. Next. Now, permanent electric dipole moment. Permanent. Here, one is permanent electric dipole moment. Okay. And another one is what? Induced electric dipole moment. Induced electric dipole moment. Here, what is permanent electric dipole moment is, even in the absence of the external electric field as also, please listen carefully, even in the absence of external electric field also, substance, hydrochloric acid, sodium chloride, this is what? Plus, minus, minus, plus, like this, plus, minus, minus, plus, like this, it is many dipoles are there. Many dipoles are there. This is one substance, hydrochloric acid. Each molecule is each molecule is nothing but what? One dipole moment. Dipole. Each molecule is a electric dipole here. Here, even in the absence of the external electric field is also, each molecule has got one permanent dipole moment is there. That dipole moment is represented from negative to what? Positive. This also negative to positive. This also negative to positive. This also what? Negative to positive. This also what? Negative to what? Positive. But net dipole moment is 0. Net dipole moment is 0 in the absence of external electric field. In the absence of external electric field. See, listen carefully. Here, each molecule has got permanent dipole moment. Each molecule has got one particular direction. If I consider the entire system, since dipole moment is a vector quantity and all that, please listen here. This dipole moment is in this direction. This dipole moment is in this direction. Dipole moment is a vector quantity. Net dipole moment equal to what? 0. If you consider this and this, again that net dipole moment equal to what? 0. In like that, here the net dipole moment is 0 in the absence of the external electric field. Here, each molecule has got dipole moment. But if I consider the entire system, that net dipole moment equal to what? It is 0 here. It is a vector addition. Next, when such kind of material, now this one, I will apply the external electric field. I will apply it slowly. External. This is what? Positively charged, and this is what? Negatively charged. When such kind of dipole is induced, subjected to the external electric field, what happens? Here minus plus, here plus minus, because now I brought this substance under the influence of the external electrical field. Now you see, this dipole is oriented in this direction because this negative charge is attracted by what? This positive, and this positive charge is attracted by the what? Negative plate and all that. In this fashion, all dipoles are arranged in this direction. Minus plus, this is plus minus. Now that is, whenever such kind of substances are subjected to the external electrical field, this is external electrical field, I am applying. Now here, net dipole moment is not equal to 0. Because all dipoles are oriented in one particular direction, that is, all dipoles are oriented in one particular direction and all. Of course, here I have taken the perfectly horizontal, I have taken, that is. It is not the same situation in all the substances here. That is, I will come to the polarizability and all the definitions. Okay, here perfectly what they are arranged. But here you see, what is the difference? In this case, E is what? Not equal to 0. In this case, E equal to what? 0. When the external field is 0, then net dipole moment equal to what? 0. But in this situation, you see, here the external field is not equal to 0, but dipole moment, it is external field is not equal to 0, so that net dipole moment is also not equal to what? 0. This is the situation in case of what? Permanent electric dipole moment. Suppose if they ask a question, define permanent electric dipole moment. Here, there are some molecules, there are some substances, in the absence of external electrical field, each molecule possesses the dipole moment, but the net dipole moment is what? 0. That's all. You write only this much to the mark. Yes, to the point. Just you write only this much. Now let us come to the induced dipole moment. Induced dipole moment. What is induced dipole moment? Here you say, induced dipole moment, the word itself as indicates induced means this is possible in non-polar molecules. Non-polar molecules will show this kind of property. Example for the non-polar molecule, it is benzene C6H6, hydrogen molecule, oxygen molecule, N2 molecule, you see, that is like atoms. NN, HH, OO. These are all comes under the water non-polar molecules. In such kind of non-polar molecules, what happens is the center of the positive charge, this is what? Positive charge. And the center of the negative charge, both are coincided here. That is, both are, this is negative and this is what? Positive here. The net charge in this entire system, it is equal to what? 0. There is no separation. And we know that dipole moment equal to Q into what? R. But here there is no separation here, because the center of the positive charge and center of the negative charge both are what? Coincided. Here R equal to what? 0. Then dipole moment equal to what? 0. Such cases are called as in what? Non-polar molecules. What are non-polar molecules? The molecules in which where the center of the positive charge and the center of the negative charge both are what? Coincided. As a result, R equal to 0 and hence dipole moment equal to what? 0. Okay, this is about a non-polar molecule. But I forgot to tell one more, that is with respect to this, it is polar molecules and not polar force. Polar molecule. In polar molecules, example is hydrochloric acid, sodium chloride, water, I think we studied in the chemistry also, where both positive charge and negative charges are separated by a finite distance, where dipole moment is not equal to what? 0, but here dipole moment is equal to what? 0. This is the difference between the polar molecule and the non-polar molecule. In polar molecule, the dipole moment is not equal to 0. In non-polar molecule, the dipole moment equal to what? 0 here. Now, I will come to this one. Induced electric dipole moment. Okay, what is induced? Just now I told you in non-polar molecule, what happens is, this is the positive charge and this is a positive charge and this is what? There is a superimposition of what? Positive and negative charges. There is a superimposition of positive and negative charges. So that dipole moment equal to what? 0. Why dipole moment equal to 0? Because R equal to what? 0. When such kind of substance is subjected to the external electric field, when such kind of substance is subjected to the external electric, this is the direction of the electric field, student. This represents, here it is a positive and here it is a what? Negative. Here, because of this applied external electrical field, since here it is a positive, here it is a negative, so that at this point it is attracted by the what? Negative charge. This is negative and this is what? Positive. You see, these positive and negative charges are separated by a what? Definite distance here, so that dipole moment is not equal to what? 0 here, because mu equal to Q into what? R. But here mu equal to 0, because distance equal to what? 0, so the dipole moment equal to what? 0 here. This is called as an induced electric dipole moment. I define it in this way. The molecules, certain molecules, that is non-polar molecules, when they are subjected to the external electric field, certain molecules, certain non-polar molecules, when they are subjected to an external electric field, there is a displacement, there is a separation or displacement, there is a displacement of positive charge and negative charge, Okay, both of these positive and negative charges are separate. As a result, you are getting what? So that hence dipole moment is what? Not equal to 0. I think you understood this. Certain molecules, when they are subjected to the what? That is, it possesses the what? One definite dipole moment is what? Produced here. These are called as what? Induced electric dipole moment and all that. Okay. Because why I am using the word the induced is, it is created because of what? External electrical field. If I remove this electrical field, again it will go back to what? This situation. Again, if I remove this, it is again go back to this. It is as good as long as the teacher is present inside the classroom, all students are what? Polarized. They are sitting in one particular direction. The moment the teacher goes out, again all students are randomly what? Oriented in all directions. That is the induced phenomenon. Okay. This is okay. Next one is polarization. Polarization. Okay. 1 minute.